going to look at interest today. Earlier in the year we did some problems with just simple interest. So they were the more complicated problems when you have $10,000 and you're going to invest some of it at 3%, some of it at 5%, and you want so much interest, and we had to make all the tables. We're doing a simpler version right now. We are doing a different way of calculating interest, but we're not doing the real complex problems with it. Okay? So make sure you have a calculator. You're going to be plugging a lot of things in your calculator today. First thing, I just want to make sure you know what I mean when I talk about different payment periods that are going to show up. So if I say annually, what does that mean? Yearly. Once per year. What's semi-annually?
Every 2 years?
Twice a year.
Actually, twice a year. Quarterly. Monthly. And the last one,
365 or 360.
we are going to exclude leap years to make life easier. So when we talk about daily, we are going to say 365 times per year.
You have to pay that. You have to pay something daily.
Okay. So when you go to the bank and take out a loan, they're not just going to say, okay, I'm only charging you interest one time and this is how much interest you're going to owe me. What's going to happen is they are going to charge you interest and then you now have to pay more based on that larger amount, right? And this interest keeps building. So we are going to look at what's called compound interest. There are two types. The first formula on there is compound interest. In this case, A represents your ending amount, or sometimes that's called your future value. P is your principal, that's your beginning amount, or what you have right now, your present value. R is the interest rate, which has to be in decimal form. N is the number of years, number of times you are compounding in a year. And T is the number of years for our investment. The second type is continuous compounding. So we talked about compounding, annually, semi-annually, quarterly, monthly, daily. I could do it every hour or every minute or every second, and that's leading into this idea of continuous compounding. That formula is A equals PE to the RT. A, P, R, and T represent the same thing as in the other formula. E is actually a button on the calculator. It's kind of like pi. It comes from, where the number E comes from is a little more complicated. It's a calculus idea. But just know E represents like 2.7 and this big decimal that never ends. And that's what we use when we talk about continuous compounding.
Why don't you use a letter?
Did we already do a little bit of this?
Yes, you had done some of this in Algebra 2.
Pi Day's on Saturday, right?
Oh, it is.
Oh!
So we should have a party on Friday.
We should find.
I'll make a pie. I like baking. I'm sorry, that was so mean.
Maddie, it's
But I
okay.
do like to celebrate Friday.
See? You should. Yes, you should do.
I say we all go to school on
I say we
Saturday.
ditch
And
plans
every
tomorrow
single
and
day.
just find out
done.
Yes, pie.
So next Friday, you want to celebrate Friday?
Okay, read next Friday.
Yeah, because it's 3.14 March 14th.
Okay.
It's just the 5th right now. Okay. Thank
Yes.
you for mentioning that. So, can I wear my pie shirt?
Yes, you can wear a pie shirt.
I could wear all my math shirts next week. I have a lot of
Do you have pants with algebraic expressions on them?
I'll just come to school wearing a pie costume.
Okay. So every problem we're doing today is going to involve one of those two formulas. If I say the word continuous, that's when you use the formula with the E in it. Otherwise, you're using the first formula. So, first example. Find the future value of $100 invested at 4%, compounded quarterly after a period of 13 quarters, and B, the amount of interest earned. I encourage you on these problems to write down the things that you have and what you need. I want the future value. What is future value? What variable? A. What is the 100 going to represent?
T.
P, the present value, principal, what we have right now. Okay, 4%, that would be the rate, but I don't want to plug in a 4, we have to do 0.04. Compounded quarterly, if it's quarterly in, the number of times per year would be 4. After a period of 13 quarters, okay, we have to be careful here. T is our time, but it has to be measured in years. So 13 quarters would be how many years?
3, but you use 1.
Okay, just do, we know how many quarters are in a year?
3,
4, so just do 13 over 4.
3 1/4.
So 3.25 years. Okay, this was just our regular interest. It didn't say continuous, so I'm using the first formula, A equals P, 1 plus R over N to the NT power. You do not have to memorize these formulas. I will give them to you, but I'm not telling you what the variables stand for, so you have to know what it means. Now we just plug in. So A equals 100 times 1 plus 0.04 over 4 to the 4 times 3.25 power. I usually just put all of this in my calculator at once. I would like for everybody to plug it in so you can make sure you're putting it in correctly.
Would you like us to write it out to show that?
Yes, especially on test or quiz. That way, if you maybe just keyed a number wrong on your calculator, you still get credit for everything except the final answer. So please do write down what you're plugging in. And what did we get?
I got 113.227.
Okay, how many decimals should we use?
At least 2.
2, because we're talking about money.
Are we rounding?
So 8
We will round.
Oh, that's
Wait, were we supposed to put like a parenthesis on all of it because I definitely.
no fraction.
Okay, did everybody get that?
I didn't get it.
Okay. This is just 2 times
We have 4 stations
Okay, anybody else need me to look at their calculator?
They're not third graders.
Okay, so part A said find the future value, so that's that. Part B was the amount of interest you earned. How would I do that? Subtract. We end with this much. We started with $100.
13.9.
So we earned $13.81 interest.
You can buy so many things for $13.81.
The dollar store by 13.
You go to the line.
So your ending amount minus what you started.
How did you do that? You just subtract 100? Whatever P is.
Yep. That was cool enough. Okay, let's look at some more. Leah must pay a lump sum of $15,000.
Well, what did she do to get herself from that?
Part A. What amount deposited today at 4.8% compounded annually will give $15,000 in 42 months? So, What's this 15,000 represent? A. That's what we need to end with. So what amount deposited today, that represents P, what we start with. We don't know. My rate would be 0.048. If it's a percent, you move your decimal back 2 places. Compounded annually. So N is how many times per year? 1. And my time, if I'm talking about 42 months.
3.5 years.
Right. You just have to do your 42 divided by the 12 months in a year, so my time is 3.5. So now I'm going to plug into A equals P, 1 plus R over N, the NT power. My A is 15,000 equals P, 1 plus 0.048 over 1 to the 1 times 3.5. Okay, we are solving for P here. If you want, you can clean it up a bit. You don't necessarily have to. 1 plus 0.048 divided by 1, which is 1.048. 1 times 3.5 is 3.5. How would I get my P by itself? Divide. So P is going to be 15,000 divided by that. And round to the nearest cent, we get $12,729.95, I believe. Which makes sense. If she's wanting 15,000, thinking she's going to start with 12,700, that seems reasonable.
Did we get that?
Part B. Okay, let's say she doesn't have that much money. She only has $10,000 right now. What annual interest rate is necessary for the money to increase to 15,000 in 4 years? Okay, so now my ending amount is still 15,000. The 10,000 is P, what we have right now. Do I know my rate? No, that's what we're going to solve for. N, I did not specify. We're assuming it's the same as part A, compounded annually. So we're just going to do once per year. T, how long is she going to put it in this time?
4 years.
4 years. So if we solve, my A is 15,000 equals P, 10,000. 1 plus R over 1 to the 1 times 4 power. Let's clean this up. What could I do with my 10,000? It's multiplied, so we have to divide.
Wait. Oh, okay, never mind.
You sure?
Yeah, I was like, why are you dividing it by the 1 plus R? Like,
Oh.
it's just multiplying back. It should be
So what's that give me?
1.5.
Okay. Here we have 1 plus R divided by 1 is R. 1 times 4 is 4. So I'm trying to get to R. How do you get rid of the 4th power? Fourth root. Normally with an even root we add a plus and minus, but will you have a negative interest rate? No, so we don't have to do the negative here. I'm not going to plug this in my calculator quite yet just because I'm trying to eliminate rounding error. What would be the next step? Subtract your 1. So we have the 4th root of 1.5 with a minus 1 on the end. That's what I'm going to put in my calculator. Make sure that -1 is outside your radical. So I get 0.10668. So in other words, she would need 10.668% interest right now for this investment to work.
So whatever we get, we have to move the decimal.
I would. If I will accept it either way, you just make sure if you move your decimal, you put the percent sign. Otherwise, you leave it off. Okay. Does that make sense?
Can I ask how, do you always go to 3 decimal points afterwards unless you're talking about money?
Yeah, usually. Do you guys know if you're going to invest your money, what's usually associated with a higher interest rate?
A
Longer period, and also a lot of times more risk involved. You know, if you're talking about investments, there's a reason your savings account earns very little interest, whereas if you're going out and buying something a lot more risky, you'll get a higher return, or you could lose your money. So there's that involved.
So what if you did a longer interest, but like you pay it off like quickly?
When you
Like,
take out
so
a loan?
Yeah, so like say I did something that had a low interest rate,
Mhm.
and then I just paid it off super
Oh,
fast.
yeah, I
and
mean,
then
you'll save yourself that interest on whatever
so I
time.
still would have to get, but would it still be lower than a short interest?
It will depend on the scenarios. You would have to look at, you know, if you're talking about like buying a house, you probably want to, if you can swing a 15-year loan over a 30-year loan, that'll probably be more beneficial to you. But if you can pay that off earlier, you're definitely going to save money. Now, you would have to compare the actual interest rates if they were offering you two different things and actually see when can I feasibly pay this off and which one would be the best rate for the time frame I'm looking at. Other questions? All right, let's look at this one. Actually, I think for the sake of time, I'm actually going to skip that one for now. So I want to go to this one. Find what investing $1,000 at an annual rate of 10% compounded continuously for 2.5 years would yield. When I say compounded continuously, what does that tell me? We're using that other formula. Okay, what is my A here? Do we know? No. What is my P?
Or the 1,000.
1,000. My R would be 0.1. And my T is 2.5. P equals 1,000. E is a 0.1 times 2.5 power. The E button is on your calculator, like the third one up from the bottom on the left. There's an LN, and above that it has E to the X. So you can hit second LN, and that'll bring up your E to the X. Anybody questions on putting that in?
You said E is like pi, and pi's number is 3.14, whatever.
I just meant that E has an assigned number, so if you want like the actual number for E. Yep, you should get $1,284.03.
So you would,
Yes, you round as needed. So since it's 0.025, the 5 makes me round it up to a 3. Questions there? If I asked you for the interest earned, you would, but I didn't ask that on this question. All right. Let's do a few more, just to make sure we've got this. Find the present value of $100 after 2 years at 6% compounded monthly. So what is my A?
We don't know.
Do we? I want the present value. Present value is P. So that means P is the thing I don't know, so the 100 has to be my A.
Okay.
After 2 years, so my time is 2, at 6%, so my rate would be 0.06. Compounded monthly, so N would be 12. So I'm using the first formula. You are welcome to simplify this, but you could just go straight to putting it in your calculator if you want. So if I'm going to try to type all this in my calculator, I'm doing 100 divided by, and then that parenthesis 1 point plus 0.06 divided by 12 to the 12 times 2 power. Should this number be more or less than 100? Less. We want to end with 100, so it should be less right now. I believe we should get $88 instead of 2 cents. You put 12.2. So they're both going to say compound. It's equal to C continuously. Okay. Other questions?
Okay, I'm on your side. Bless you.
You divide by
How many dogs do I have?
That's why I put everything in at once. Just type this in and round it, it will grow. So that's why I just did 100 divided by and I typed the whole thing. Okay, anything else? Let's see. How are we feeling with this stuff? I've got 3 examples left. We don't necessarily have to do all of them. Let's try this one, and then the last 2 we'll say are optional. What annual rate of interest? So what am I looking for on this one?
Annually.
I'm looking for my R. Compounded semi-annually. What's that telling me?
Twice a year.
And this 2. Should you seek if you want to double your investment in 5 years? So my time is 5. Okay. I'm not talking about continuous, so it's still the A equals P 1 plus R over N to the NT, but I didn't tell you A and P.
Okay, so for the N, so like if it's 2.5 years, we put that there, but also if it's twice a year, we put 2.
N is number of times per year, so that would be twice a year. If it were 2.5 years, your T would be 2.5. Okay, so I didn't tell you A and P. What are we going to do for those?
Yes.
Guess. Okay. If I
Start plugging them in.
started with $10, how much am I going to end with? 20 because I'm doubling. So could I just make up a number?
Go ahead.
Yeah. You could pick whatever number you wanted for your principal and then just double it for your A. So what do you want to start with? 10. So we end with?
That's where I want to start.
Okay. So I'm going to plug this in. And whatever A and P you pick, as long as you double the P, you will get the same answer. What would I do first here?
Guess. Last time I said that it was right.
Oh, wait.
Should we just
Divide it.
Divide that. So we get 2 equals 1 plus R over 2. 2 times 5 would be 10th power. How would I get rid of the 10th power? 10th root. We don't need plus and minus because we know we're not going to deal with a negative interest rate. You don't want to plug that in your calculator yet because if you round now, your interest rate will be off at the end. So what would be the next step? And then multiply by 2. So I'm going to type all of this in now. On this, your interest rate, I usually go 4 to 5 decimal places. So either one, or you can just say it as a percent.
See, I didn't get that. Maybe I put a negative instead of a minus.
So yeah, divide by -1.
Other questions?
I have more examples if we need them. There's another one. The next one is about tripling. Then the last one is another continuous interest. So using the E formula, do we need to do either of those? Yeah. Let's go to the very last example. Find the amount in an account if $2,000 is invested at 8.5% compounded continuously after 2.25 years. So, what am I looking for? A. What's my P?
2,000.
What's the 8.5? Rate would be 0.085. And the 2.25 years would be T. I'll put 2.25. Because I see that word continuously, that tells me I'm using the A equals PE to the RT formula. So A is 2,000 E to the 0.085 times 2.25 power. our answer be more or less than 2,000? We're going to end with one start. So $2,421.52. Make sure if it's money, you are putting your dollars and 2 decimals. Is there anything else you want to talk about? Yeah. If you are okay with this, you can start the homework. There is a handout posted on Classroom.